a spontaneous reaction, since without electric current these ions were there in mobile state in electrolyte, there was no reaction, right? So this is a non-spontaneous reaction, right? Because when we turned on electric current, then this reaction has occurred, right? So we say that it's electric energy caused chemical reaction, right? So you just need to understand how electric energy will cause chemical reaction, right? When electrons will start moving towards respective electrodes, they will, at cathode they will gain electrons, at anode they will lose electrons, right? And due to this gain on loss of electrons, the products are formed at cathode and anode, right? So these are the products, M and N, right? And now you need to just understand one thing here. Just notice one thing, that here one electron was gained and here one electron was lost, right? So this is common in all electrolytic reactions, that number of electrons lost would be equal to number of electrons gained, right? So I'll just mention this point. Number of electrons lost is equal to number of electrons gained in electrolysis, right? Now there is one more thing. We have already studied this in previous classes about redox reaction, right? What is a redox reaction? When reduction and oxidation takes place simultaneously, we call it as redox reaction, right? So we have mentioned here at cathode reduction is taking place, right? And at anode oxidation is taking place, right? So since oxidation and reduction are taking place simultaneously in this process, right? So we call it a redox reaction. So we say electrolysis is a redox reaction, right? I'll just mention it over here. Just take down all these notes, because this is very important to understand this chapter, right? Because after this you will see all the we have all the electrolysis of different chemical compounds, right? So electrolysis is an example of redox reaction, because oxidation and reduction are taking place simultaneously. In this electrolysis, right? So this question has been asked many times, that electrolysis is an example of redox reaction. Why? Right? So here now we understand why it's an example of redox reaction, because oxidation is occurring at anode, reduction is occurring at cathode, right? So since both these reactions are occurring together simultaneously in this arrangement, right? And this is an arrangement of electrolysis. So we say oxidation and reduction are taking simultaneously in electrolysis. So that is why it is an example of redox reaction, right? And remember that the number of electrons lost is equal to the number of electrons gained, and electric energy caused the chemical reaction to occur. Now, since one more important point, since these products are formed at anode and cathode, right? So since we are getting products at anode and cathode, right? So the product that are deposited or that are formed at anode and cathode, right, would be directly proportional to the quantity of electricity that is passing through the electrolyte, right? That is, more is the electric current that is passing through the electrolyte, so more is the mass of the product formed at the electrodes, right? So we say that mass of the substance formed at the electrodes is directly proportional to the quantity of electricity passed. More the electricity, more electric current you pass through it, more the quantity of products that you obtain at electrodes, positive and negative, cathode and anode, right? And this is known as Faraday law of electrolysis. That you don't have in your syllabus, you have that in class 12th. So mass of product obtained at electrodes is directly proportional to quantity of electricity, right? It is directly proportional to the quantity of electricity. So just take down all these notes, right? I'll just quickly revise what we have done in this lecture. This apparatus is known as voltameter, right, or electrolytic cell, in which we carry out the process of electrolysis, right? And these metal rods are called electrodes. A cathode, that is a negative electrode, and anode means a positive electrode, right? And this is connected to source of direct current source, right? That is the battery, right? And when electric current is turned on, right, we have directional flow of charges, right? Directional flow of charges, that is, cations will move towards cathode, anions will move towards anode. And there is a way to remember: C to C, A to A, right? So electrolytic conduction is conduction due to mobile ions, right? And when cations will move to cathode, cations will, right, first here, this point, cations and anions will migrate to cathode and anode, and movement of positive and negative ions will allow electric current to flow. It is due to the movement of these ions that this electrolyte will conduct electricity, and electric current will flow through this electrolyte, right? And at cathode there would be gain of electrons. So cations will gain electrons at cathode, which is known as reduction. Anions will lose electrons at anode, which is known as oxidation, right? And these are electrode reactions, right? And the product of electrolysis are obtained at cathode and anode. These products are obtained at cathode and anode, right? So we have also studied that it's electrical energy that caused this reaction, right? Before electric current, these ions were in mobile state, but there was no reaction, right? So that is why we say it's electrical energy. When this electrolyte has absorbed electrical energy, this reaction has occurred, and we obtained different products at respective electrodes, right? And electrolysis is an example of redox reaction. Why? Because oxidation and reduction are taking place simultaneously, and mass of product obtained at electrodes is directly proportional to the quantity of electricity, and this is also known as Faraday's laws of electrolysis. And these are all important points, right, that you need to remember, right? And this is common. All these procedures would be common in all the electrolytic processes. So if you will do this video properly, rest of the electrolytic processes would be very easy for you, right? So I hope all this is clear to you, right? Thanks.